5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
So, software for satellites. We are overdue to talk about it. It's important and it could be a big business opportunity for reasons you'll hear about in this episode. My guest is Alvaro Alonso Ruiz, co-founder of the French startup Leanspace. They have raised a €6 million seed round late last year. Enjoy.
My name is Raphael, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with the CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space. Hey, space enthusiasts, time for another episode. My guest today is Alvaro Alonso Ruiz. He's a co-founder and chief commercial officer of a Strasbourg-based space startup called Leanspace. Welcome, Alvaro.
Thank you for having me.
No, it's our pleasure. So, Alvaro, as usual, I'm going to ask you as the first question to please give us the elevator pitch on Leanspace.
Sure. In Leanspace, we're working on the ground segment and satellite operations side of space missions. Today, there are two ways to build ground software to manage the space missions. You can buy products, which are convenient because they are fast to configure, but they serve the one use case. So as each space mission tends to be unique, a lot of companies actually decide to build from scratch, which is the second way to build. Building from scratch has a lot of advantages because you can build something close to your use case. But of course, it takes years and it costs a fortune. Our breakthrough at Leanspace was to see that although every space mission is unique and needs custom tools, 80% of all the software is always the same. And I'm talking about software to move data, decode data, store data, monitor data. It's always the same thing. And it's always this 20% on top, which is custom to the use case.
Mm-hmm.
So what we did at Leanspace was to decouple this 80% with the 20% on top. So what we have built is this 80%. We make it available as a cloud platform dedicated to the space industry. So the technical name is Platform as a Service. And we make available this 80% as building blocks. It's basically all the generic functions of ground software. And our customers use them to develop their custom systems for satellite design, hardware testing, satellite operations, managing the ground networks, and the real value that this has is that space organizations using Leanspace, they can build their custom software systems, but drastically faster, drastically cheaper, and on a much better technology. And everything they build is natively connected, which solves the problem of like companies procuring point solutions that solve individual problems but don't talk to each other. What we do at Leanspace, we didn't invent anything. So what we do has been done previously in many other industries. So for example, a company called Backbase did it for finance. Viva did it for health tech. Shopify did it for e-commerce. We're bringing this new way of building software for the space industry.
Okay, understood. So just to clarify, you are basically a software company. When first you started talking about the ground segment, and maybe some of the listeners imagine satellite ground stations, but you're not doing any hardware, right? You're purely a software company.
That is correct. The ground segment consists of the ground stations, which is basically the antenna that connects to the satellites. But then you have a lot of software that is managing the mission. Throughout the life cycle, software from the mission design to the building and testing of the hardware to running the operations, to delivering the products to the user. Space missions are run through software, and that's what we do.
Okay, but there's of course also software on the satellites. So again, just a clarifying question: are you guys also including that, or is it really just the software that's running on the ground?
We focus on the software that is running on the ground. That is the software that is, let's say, managing the mission as a whole. Yeah.
Okay, understood. And before we dive into like some more details on sort of, what the full product cycle looks like, which I'm curious about, let me ask another question that I usually like to ask is like, how did you guys, like, for example, what's your background? And you're one of the co-founders, and sort of how did you guys come up with doing this? Why did you think it was important to do this?
Well, I mean, Leanspace, we are 4 co-founders. We're all engineers. And we have been operating the space industry for many years. And as I would say, as every good startup, Leanspace came to be out of frustration because the co-founders of Leanspace, we have worked, the 4 of us, previously in other industries, and we saw how advanced they were on their digital journeys. And when we landed in space many years ago, we saw the software tools that are used to manage space missions. And we were pretty surprised on the legacy technologies that were used, on the old school approach to building ground infrastructures. And we have been working for space agencies, for big space enterprises, but also with new space startups. And the story was repeating itself. Every company, they were rebuilding things from scratch. In space, we saw that traditionally there is a very, very big focus on the satellite, the rocket, the fire at the launch. We really like those things. And software was always a second thought. It was never important. In the past, when space missions costed an arm and a leg, and the software was a very small part. And when typically when space missions were for like more space exploration kind of thing, budgets were never an issue. Timelines were never ending. It was not a competitive environment. So you could afford to have like an army of engineers doing things manually. You could afford to have massive delays in space missions, but it's not the case anymore. And when we were working in the space industry, we saw that the industry was commercializing itself, but the mentality of the space engineers was not shifting into a more digital way of doing things. And again, the satellite is just an asset. It's like a laptop for all that matters, right? It's an asset that does the thing. But the way you operate this asset, the way you optimize these operations, the way you increase the efficiency of your business, the tools you use to actually run your business from the beginning to the end, everything is the software on the ground. So we were very frustrated seeing that other industries were a decade ahead of space in this digital journey. We were surprised that space engineers, we thought that space was different. It was like a state-of-the-art technology, but in many aspects we were like so much behind. So we thought to build Leanspace to actually bring these digital technologies and digital transformation to the industry.
And related to that, why did you call it Leanspace? I mean, do you think current space is like bulky, or maybe it's like lean startup philosophy, or what's the origin?
Yeah, basically, it's a play on words. So actually, what we want to do is to make space lean. Right now, for example, when you are building a new space mission and you have to put together a ground segment, just putting together the software on the ground, this takes months to years. There's a lot of legacy technologies used, so a lot of software doesn't scale. So, for example, we see all these mega constellations, but then like the software used for the one satellite, it doesn't work when you have 10, 100, 1,000. It doesn't work. It doesn't scale. We saw all these hurdles that don't make space missions lean, that they bloat budgets significantly, make space missions super long, super delayed over and over again. Our vision is to make space lean, so that any new company that comes to the industry, they can just build a ground segment in a matter of weeks instead of years. Scalable, cloud native, and even the existing satellite operators that are a bit stuck with old technologies, we allow them to make a transition to these new digital technologies in a very easy way to make their companies more efficient.
No, I was going to now jump to the sort of product cycle, right? So I think motivation is understood by now, but let's delve into more detail in the product cycle, because we're a non-technical podcast, and so listeners may not be aware of exactly what software does on the ground. So maybe, either hypothetically, or if you want and can use an actual customer as an example, sort of like from the very start, from I guess the design of the spacecraft to on-orbit operation, like where do your software libraries come in and what do they do?
Today, we're focusing on satellite operations. So I'm talking about sending commands to the satellite to tell it what to do, receiving telemetry, decoding it, to check the health of the satellite, monitoring if there's any anomaly, managing your ground network, the ground stations to actually communicate with the satellite, planning activities on the satellite. Like, for example, if we talk about Earth observation, taking a picture of a specific location, performing flight dynamics, propagations to see where the satellite is, where is it going to be, doing on-orbit maneuvers, and then moving a bit upstream, also like hardware testing. So managing test cases, managing performing checkout systems, using the same tools to test the hardware and then use to operate, having all these tools connected. So that is a bit where we sit today. But again, our vision is to connect the entire life cycle of the mission together. Because today, how companies procure the systems, they basically procure point solutions. So they buy the one software for doing the satellite design, another software for managing the tests, another software for managing the command and control, another software for managing the flight dynamics. And all of these softwares, they work individually. They're not connected to each other. They don't share data. And the problem with this is that data is locked in silos. And if you need to, for example, automate operations, you need your tools to share data amongst each other. If you want to reduce errors in your data, or you want to increase your speed and efficiency, you need your teams to work with the same data formats or the same databases. Because today you have different teams working with different data. You have teams moving data manually from one to another, working with different versions of the data. Configuration management, it's a mess when you are talking about constellations. So this is where we see the industry, the next step in the digitalization of the industry. This is where we see it is. The industry needs, let's say, a platform that connects end-to-end the mission lifecycle. And on this platform, then you can build all of these custom solutions for the design, the testing, the operations, and you can also connect third-party systems, third-party services, have a fully integrated ecosystem end-to-end.
So it's kind of like, I don't know if this is the right comparison, but sort of like, 3 to 4 decades ago, it's like what, SAP did for all of the business functions kind of thing. Like you envision to kind of have this full ecosystem for space. Yes. I mean, there's a significant difference. But I mean, your analogy is correct in the sense of the vision of connecting everything together. The difference between SAP and us, I mean, apart from the technology, is that SAP basically is a vendor lock-in. So when in the past, when a company goes to SAP, you need to hire the SAP consultants to do things for you. You need to buy the tools from SAP. So then you're locked in, and at the end, it costs a fortune. What we have in our platform is basically a collection of APIs. And you take the ones you need to build the systems you need. These APIs can be replaced. These APIs can easily connect to any third-party tool. So for example, we have customers using their own software for command and control of the satellite, and they use Leanspace for the mission planning part. Yeah. That was going to be our next question, whether you're doing, because this is very ambitious, right? Whether you're doing everything in-house or whether you are able to, collaborate with third-party software and applications, and it seems the latter. You are able to cooperate with third parties.
That is correct. Building everything in-house, it makes no sense because it's too much. It costs too much money and it takes too much time. Let's say what we want to be is a platform that connects everything.
Okay.
We are providing some building blocks that can be used to build all these systems, but what we allow is that other companies and our customers build these, let's say, added value systems on top. For example, you have a lot of companies that are building really advanced AI-powered algorithms for automation, for anomaly detection, for advanced decision making.
I was actually, if I can jump in, I was actually going to ask you about two specific sort of things I can think of, and also they're tying back to some extent to previous episodes of the podcast. So one is, we've had several people on already on the podcast talking about the whole space debris topic, and people who are doing things like conjunction warnings, right? Which, I mean, you were talking about that one of the things your software can do is send commands for maneuvering, right? And so I immediately thought about conjunction warnings. So, for example, is that something you could tie into your platform? Like, we had, for example, Arise from Kehan Space, and there's obviously other companies like Okapi in Germany. Are those people who could collaborate with Leanspace, and you could tie their own like data feeds into your platform?
Definitely. I mean, we're partnering with these companies, and the interesting thing is that today, if you have a tool that tells you the conjunction warning, you have a different system that calculates the maneuver that you have to perform to avoid the collision. And then you have another system that does the planning, optimization and updating. And then you have another tool to send the commands. You're going to need someone to actually move data from one place to the next. And hopefully he won't make any mistake, he or she. What we do is we connect everything together. So we actually allow satellite operators to automate this workflow end to end. So you get the conjunction alert, and automatically you can trigger an orbit propagation to see, how this collision will happen and when. Then you can actually activate automatically this avoidance maneuver. You can even have several scenarios. You can even compare different scenarios. You can have a human in the loop in the points that you want, for validation. You can then automatically update the mission planning and automatically send the commands. And with all these mega constellations being launched, these things cannot be done manually anymore. Raphael, a few years ago, I think in 2019, there was this almost collision between a Starlink satellite and a scientific satellite from the European Space Agency. And a few days before, they both got this collision alert. And they were talking to each other on the phone and sending emails to each other. Hey, can you move your satellite? No, you move yours. No, you. And at the end, they didn't reach an agreement. And then ESA had to do like a emergency last minute avoidance maneuver. It was the first time in the history of ESA they had to do this. This was highly publicized and whatnot. But the fact is that with all these mega constellations, these things have to be automated. You cannot do these things manually and sending emails at 3 a.m. on a Saturday. It makes no sense. We connect all these third-party services with all the infrastructure satellite operators have. And even in the future, we will connect operators between themselves so that all these things can be automated. Okay.
And I guess the interesting thing is, so in theory, the more customers you have, you have sort of like an ever-growing pool of data, right? Including what's going on in orbit, right? Question though is, so to some extent it could be good because, I mean, you were talking sort of about people using AI for anomalies. And I guess, if you had a really giant pool of data, then I could see, being a machine learning guy, I could see how that data set would help in things like, building really good anomaly, like predictive maintenance, anomaly detection type algorithms. The question though is, can you really mingle that data? I can also see, knowing the space sector, I can also see some customers who would be very upset if their data gets mingled with other data.
I mean, of course, our customers own their data and we cannot access it and we cannot use it. But I mean, the point you're making is extremely good. A few weeks ago, I was in Silicon Valley for an event, and I was actually on a panel about AI. And the recurring topic, all the panelists, they were working for companies performing super advanced AI algorithms, and they were all saying, "We have the tech. What we are missing is the data. We don't have enough data to actually train the models." That is where Leanspace comes in. That is why I was in the panel. What we allow is for satellite operators to have all the data available And it's not only the data from now, but from the last 10 years. And with this data, they can actually train the models. We allow companies to have all the data centralized from the design phase to the test phase to the operational phase. So it's not that we train algorithms, they can train their own algorithms. So we allow them to actually utilize these AI-powered tools, because again, these tools, what they provide you are insights. And if the data in is garbage, garbage in, garbage out. So what we allow companies to actually utilize all these advanced AI algorithms and make use of them to make an impact in their operations.
And so while we're on the topic of AI, of course, I have to ask because it's so timely. So I heard yesterday through the grapevine that another sort of, let's call it the space-related software company, I'm not going to say the name because I'm not sure it's public, is now integrating ChatGPT functionality into their product. Is there, just because that's such a big topic at the moment, I have to ask, is that something like you guys can see yourselves using somewhere?
Not really, because again, we are not an AI company. That's what our partners do. What we provide is the infrastructure, the digital infrastructure of the space industry. We're creating an ecosystem where a lot of other companies can do all these value-added systems and services. And what we are the glue that connects everything together.
Okay, understood. And so while we're on that architecture, so basically you guys said, I mean, you're basically a collection of whatever you call it, libraries and APIs. And you said it's all based in the cloud, right?
Yeah.
And so one question I also have to ask here is, I mean, one way, I mean, you mentioned some other, examples, and if I remember correctly, and sometimes you guys also talking about Shopify as an example. So of course, one big difference is sort of like, if somebody hacks Shopify, that's pretty bad, but it's probably not ending the world. Like space is extremely strategic and there are clear adversaries, trying to, if you're talking about the Western world, trying to hack our systems all the time. So if I hear about stuff moving into the cloud, it inherently makes me very nervous. Like, how do you guys think about cybersecurity?
Yeah. This is a very hot topic. And the interesting thing is that a lot of people think that their data is safer in a server in their basement than in the cloud. And the fact is that it's not.
Yep, depends on, not in my basement, but it depends on the basement, I guess. The basement is inside a Swiss mountain guarded by military. It's a different story.
Yeah. I mean, and of course, for some military applications, and there are edge cases, right? But the cloud is extremely secure. And for example, one of the things that we enable that is a massive security boost is a centralized security from data management. Going back to what I said before, when you have all these different software tools to do different things, which are disconnected to each other, you have a lot of different usernames and passwords. You have to move data from one to the next, and when you move the data, that is not protected. There's a lot of let's say points of breach. What we do, because everything is connected, we have a security parameter which centralizes all the authorization and authentication of all your users. It encrypts all your data end to end, from the antenna to the cloud and everything around. You have a much better way to manage your data, much better and much simpler and much more powerful. And this you can only do if everything is connected. So we also, for example, we're sitting on top of AWS today, and we work with them very much on advancing these security features. And we are, for example, we're having a lot of commercial traction with SATCOM operators, so operators operating geostationary satellites. That in the past they had a big concern on cloud technologies, and now actually they see Leanspace as a way to improve the security of the data.
Interesting. So that's a nice segue into sort of the next topic I want to talk about, which is sort of your customers. Who are your customers and your target market? And you mentioned sort of traditional, the geo operators. I don't know if you were talking about traditional ones or there's some newer ones as well. But if we start with sort of traditional companies, because there's obviously a lot of existing, traditional geo operators, for example, have been around for a while. I've always, by and large, known them to be fairly conservative people. How has it been approaching them with like a sort of a new way of doing things?
Yeah, it is true that the space industry as a whole, and of course, let's say the legacy operators have a very traditional mindset. But digital transformation today it's just a strategic competitive advantage, but it is also unavoidable. It's you cannot stop this. When all the industry is digitalizing itself, using digital technologies to become cheaper, faster, more efficient, you cannot just fall behind, because you will become obsolete and eventually you will fade away. The CEO of Microsoft, Satya Nadella, a few years ago, he was on stage and he has this famous quote. He said, every company is a software company. When your business entirely is run through software, because of course companies have assets, you have hardware assets, but you run your business with software. You have to start thinking and operating like a digital company. So it's no longer about just procuring the one solution and deploying the other one here. It's not about a simple software solution. It's about these companies have to start thinking of their own future as a digital company and leveraging a platform like Leanspace, which connects the entire brain of their business and their space mission. I don't know, you can just leapfrog your competitors. And this is something which, again, is a strategic competitive advantage, but it's unavoidable if you want to stay relevant in the coming years.
And I mean, speaking about leapfrogging, that's of course, so if we talk about not operators for a second, but about satellite integrators, that's of course what there's sort of this breed of more recent satellite integrators that are obviously trying to do exactly that, not only on the software front, but sort of I guess on the integrated hardware and software front, right? So, names like, Apex in the US that just got funding from Andreessen Horowitz last year, or Reflex in Germany that also just got funding. Is that those kind of people strike me as sort of natural ones for you guys to go to? And maybe because they're also just starting and designing the process, it's kind of you don't have to deal with any legacy issues. I'm assuming you're approaching these people as well, and how's that going?
Well, definitely. They're natural partners for us. In the space industry, we still have this traditional mentality of building everything in-house. And a lot of people think, because that's how we have been doing things for decades. But this mind shift is changing. For example, we had some discussions with people at Planet. And Planet, I cannot say the name, but one of their executives, he told us, look, if Leanspace would have been around, when we started the company, it would have been a no-brainer. Planet, and this information is public, but their OpEx is 50-60% software, and the rest is hardware. And actually, Robbie Schingler, he said at one point that when he started Planet, he didn't realize he was starting two companies, a software and a hardware company, and how eventually the software company actually became bigger. And when your business is not software, because the business of Planet is not software, the business of Reflex and Apex is not software. Their business is different. It just makes sense to leverage companies that can do the software part better than you and can enable you, because that is how you actually accelerate and optimize costs, leveraging the ecosystem of partners, not just rebuilding everything from scratch. So yes, these companies are natural partners, customers for us.
It's funny you mentioned Planet. I mean, we're not going to talk specifically about competitors here, but I mean, as you and I know, there's two former C-level executives at Planet that basically set up a company that's in some way similar to Leanspace. So that's kind of completely validating the market, right? In my mind. But there's also part of something, wider that's going on here, right? Because there's companies like Leanspace, but then there's also companies tackling other sort of, elements of software use in aerospace manufacturing, companies like Epsilon 3 or Continuum or Azimuth. And then there's other people who are trying to improve the actual hardware, manufacturing side, right, of aerospace, like Hadrian or Additive Space Technologies, right? There seems to be sort of consensus view that the traditional way of aerospace manufacturing is just not very optimized, let's put it this way. So you have all of these other new players, some of them with, pretty good funding. Are you interacting with some of those guys as well, both on the software and hardware side?
These companies are natural partners also. So again, we don't provide the solutions that these companies are providing. We sit one level below. We are the space infrastructure. And what we enable is that all these companies can build the point solutions and just focus on that. And they can do it much better and integrate with the whole ecosystem. The story we hear over and over again from all of our customers and the space companies we talk to is that one of the biggest pain points is having an integrated infrastructure. It's because, again, when you want to scale a company, again, not talking about specific examples, but and I don't want to name them, but there is a big constellation of satellite communications satellites in LEO. Mm-hmm. It's a company that has many of them already in orbit, and they built their ground segment using a very traditional approach. The traditional one, right? You procure the different systems from different vendors and whatnot. And the thing is that these point solutions are not meant to scale. They're not meant to talk to each other. So, the mess, like stitching all these different technologies together, maintaining these interfaces, it became an amazing mess. I was very close to this project, let's say, and they poured like millions and millions of dollars on this. And they have a massive team of software people just maintaining this thing alive, while it is not their business. So we see this happening over and over again. And then you see other companies which take more digital approach, and you see that they are extremely more efficient in how they can operate their businesses.
And you're, it's this kind of development that is kind of natural, and it should happen, that people really realize what's not their business, and then ideally just focus on what is their business. And that's sort of similar to another big trend in space, I guess, that's going on, is that, you mentioned Planet really built everything themselves, right? Because they didn't really have a choice, right? Because they started from memory in 2010, and 2010 space looked very different from what it looks like right now, fortunately. But of course, now a very big trend is, like, let's say if you started like a Planet or like some other EO or even some space applications company today, right? You don't have to do everything yourself anymore. You can basically go to sometimes called constellation as a service or space as a service providers, like Spire does it, and Durasat does it, Astro Digital. There's more and more people doing it. So the question I was going to get to actually is, in your sort of commercial efforts, you go to market, do you approach these sort of space as a service companies and the integrators because they are almost like potential multipliers, or do you actually, or I should say, or do you also go to the actual operators?
We go to everyone because that is the power of this 80-20 approach. For us, like for the operators, we give them the tools for them to build the custom solutions to manage their specific workflows and to manage the specific characteristics of their mission. For system integrators, we give them the tools to build ground software, which is application agnostic, because it happens that they will build different satellites of different sizes, potentially with different protocols, with different payloads for different customers. So they need software tools that are actually agnostic to the technology on board the spacecraft. So we enable all these use cases, and it's even more. So we have today customers that are launcher companies. We have customers which are managing ground networks. We have customers doing debris removal, space debris removal. We have customers that are Earth observation constellations, IoT constellations, geostationary satellite, SATCOM satellites. We serve all these different use cases, again, because we have the 80%, which is the generic infrastructure, with the 20%, which is the specific part for the use case. And this is so powerful. This is so powerful.
So keeping this all in mind, and sort of, what you guys want to do at Leanspace, but then also sort of this wider market we started discussing now about, aerospace, manufacturing, and then asset operation. I don't know, like, pick a right time frame, whether it's 5 years from now or 10 years from now. Where do you think things are going? What would you like to see in that sort of like medium, longer term time frame?
You mean for us or for the industry?
Well, both, because you hope to be an integral part of the industry, right?
Yeah. We want to be an enabler. We want to be the digital infrastructure of the space industry. We want to enable everyone to do better space missions. We want to enable companies like you mentioned, Okapi, and there's others like ICO, and all these companies to be able to develop these powerful algorithms and make them available to satellite operators. I want companies building new space missions to do so much faster and much cheaper. I want constellations to be able to grow from one satellite to 100 just with the click of a button. I want, and this I'm not just saying. So actually, if you allow me to do a parenthesis, talking about the digitalization, last year in the SmallSat event in Utah, we demonstrated using our technology how to ramp up a satellite constellation drastically faster. So first, we are connected to some system design tools. So we had let's say a mission control system built on Leanspace, and this system was connected to this satellite design tool. So with a click of a button, all the database from the satellite design tool could actually it was imported into Leanspace and to the mission control for one satellite. And then we demonstrated live when you had this satellite completely configured, how to add 4 more satellites. And with a click of a button, in a matter of minutes, these new satellites were completely configured. And I'm talking about all the dashboards were configured, all the connections with the ground stations, all the monitoring systems, the commanding chain, the telemetry chain, the whole thing was configured in a matter of minutes. And of course, in the real life, you would need some validation, but this normally takes months. Depending on the size of the satellites, can take years. And we just did it in a few minutes. And this is because we use modern technologies. In this case, it's infrastructure as code that allow companies to do things drastically faster, automated, much easier. And this is a game changer for a lot of companies, especially for the constellations.
Understood.
So this is what I want to see in 10 years. I want to see companies leveraging our technology to actually make space missions easier, cheaper, and faster.
Yeah, take the friction out of like deploying space business models. That's what we all want. So what do you think are sort of the biggest risks to that vision?
The biggest risks, I think. The risks are that the space industry, although we believe that we are super forward-thinking and advanced, and in reality, we are extremely traditional. And I think the biggest risk is that people don't change their mindset towards a more digital engineering approach. For example, recently I was talking to an established Earth observation satellite operator. They're operating a few EO satellites since many years, a very successful company, and they operate their satellites using systems running on Windows 95.
Yeah,
Windows 95 is technology from 30 years ago. Yeah, and they were telling me about all these problems and issues, and it's a mess. But they're like, I don't want to touch it just in case. This mindset, we have to break through.
Well, just to kind of take a devil's advocate view, but this is a discussion we could kind of have for hours and sort of close it off here. But it goes back. This is why I asked about cybersecurity, right? I mean, of course, there's like stupidity, people using old systems, just whatever, because they're like stuck in their ways. But then there's like, there's this old joke, not a joke, it's a fact, right? That not insignificant parts of the global financial system are running on COBOL, right? I mean, and COBOL is like a really antique, program. But the reason is that people are just so worried about resilience and stuff breaking down. But, there has to be sort of a happy middle way, something where we have both resilience and security and can move forward, I would think.
Yeah, I honestly don't think that security and cloud are incompatible. I think cloud is the unavoidable next step, like it or not, because it has like so many benefits that not adopting the cloud is just staying in the Middle Ages. The question is like, how can we make the cloud
exactly secure
for all these edge use cases?
There's many people working on that, fortunately. So that's good. And I agree. Like we're not arguing for like not having the cloud. That would be ridiculous. But let's shift gears a little bit. You guys are based in Strasbourg. I think you are our first space company that's on a podcast that's from Strasbourg. Strasbourg, of course, is very dear to my heart. I mean, I love the city. I grew up near Strasbourg, and of course, I'm an alumnus of the International Space University, and you guys were in the incubator there, I think. Can you just give us maybe like a couple of sentences how that experience was, the ISU incubator and being based in Strasbourg?
Yeah. We actually, the 4 co-founders, we met in Germany. we were living in Germany, and we decided to start the company in Strasbourg for a few reasons. First, it's because two of our co-founders are alumni of the International Space University. Mm-hmm. It's a fantastic network of people, and not only for recruiting, of course, but also for being in the ecosystem. Then we believe that the space industry is international. So we didn't want to be a German company or a French company or a Spanish company. The four co-founders, we have 4 different nationalities. So we are Canadian, Indian, French, and Spanish. Mm-hmm. And we wanted to build an international company. And Strasbourg is a very international city.
Yeah, for sure.
And today we are around 45 people, and we have more than 20 nationalities in the team.
Okay.
So those were dear to our heart. And then again, in France, for example, we have 2 aerospace hubs, which is Paris and Toulouse. Yeah. We didn't want to be just yet one more company there. Mm-hmm. We wanted to carve our own story and create the space ecosystem that the International Space University wanted for Strasbourg back in the day. We wanted to also contribute to this. So that's why we decided to start in Strasbourg.
Right. Very happy to hear. And Alvaro, as you probably know, our last question on the podcast is always the same. It's about science fiction and whether you like science fiction. And of course, I always hope that my guests do like science fiction, because otherwise I basically don't know what to say next. But if you do like science fiction, then you could just give us 1 or 2 examples of your favorites, and it could be movies or TV shows or books.
Yeah, I'm a huge fan. What a surprise, right? I mean, I think everyone working in space is a huge fan of space, science fiction. I'm a big fan of reading science fiction books, more than watching anything. Right now, for example, I'm finishing The Expanse book series. Fantastic, highly recommended. I can recommend, for example, the Mars trilogy. Red Planet, Green Planet, Blue Planet, an amazing journey of when we actually colonize Mars, I believe that is how it's going to happen. That is how we will terraform the planet. And then I can recommend so many books, from like The Moon is a Harsh Mistress to Nightfall from Isaac Asimov, to Hyperion, for example.
Hyperion is great, yeah.
It's where do I start? Where do I finish? Right? Science fiction makes me dream, and I want a future for space. I want a future for humans in which we can spread the seed of life throughout our solar system and beyond. Because if we keep tethered into this planet, we will eventually extinguish as a species. So I see this bright future. I believe in it, and that's what we're trying to contribute to in Leanspace.
Yeah, and I totally agree that, software by very definition has to play an integral part in this. It's funny actually while you were talking and then you mentioned Hyperion, I was thinking because one thing I always try to do during this last question is to think if there's something I can think of in science fiction works that relates back to the business that the guest is doing. And I was thinking, what is it software depictions in science fiction? And I was so everything I can think of is basically the negative examples of AI going rogue, right? HAL 9000 in 2001. You mentioned Hyperion. I don't want to spoil the book; it's such a fantastic book, but basically also AI is going rogue on humanity. But that's obviously not the note we want to end up on. I think what you guys are doing is fantastic. I think software is an absolutely integral part, frankly, of everything, and hence also of the space industry. And good luck on your continued journey.
Thanks. Just one note of a good example of how AI went right in science fiction books. Please. I can recommend the Culture series.
Oh, you're completely right. Of course. Yeah. Yes. Great series. Fully agree with your recommendation.
Yeah. Yes. So and that's Leanspace will enable a future in the culture, hopefully.
That's a fantastic note to end on. Alvaro, thank you so much again.
Thank you so much, Raphael. It was a pleasure to be in your podcast.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/Space Business Podcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.